Hello everybody, I'm Ben and this is my presentation on ultra-thin silicon microcell technology. Silicon has a diamond crystal structure and is very abundant in nature. For example, it can be found in rocks and sand. It has a band gap of 1.14 electron volts, which works well for semiconductors. This band gap has a cutoff wavelength of about 1160 nanometers, so it covers the majority of the solar radiation spectrum needed for efficient solar cells. There are three atomic configurations: amorphous, polycrystalline, and monocrystalline. Amorphous has a random configuration. Polycrystalline has local groups of periodicity. Monocrystalline is completely periodic, making it very predictable and the choice for high-quality semiconductors. Silicon can be doped with impurities to form N-type and P-type regions, as seen in diodes, transistors, and solar cells. Due to being non-toxic to humans, it can be used in a wide variety of applications. One such application is ultra-thin solar cells. Traditional solar cells have a thickness of 180 to 500 microns and are fragile, whereas microcells are less than 20 microns thick. Being this thin allows silicon to be flexible, unlike a traditional wafer. One research group has reported cells with a 4.9 millimeter bending radius. It also greatly reduces the weight and can make the material semi-transparent, and can decrease the amount of material needed by approximately 30 times. Microcells can be formed by repeated processes of thinning 111 plane orientation silicon wafers by lithography and etching. Microcells can also be formed by chemical vapor deposition and sputtering processes on the thin films. A traditional silicon solar cell has a max efficiency of about 25%. Unfortunately, the efficiency of microcells is less due to using less silicon. So researchers have worked on techniques to improve efficiency by creating anti-reflection coatings and etching structures to trap light. A maximum efficiency of 16.8% has been reported for 20 micron thick cells and 8.5% for 3 micron thick cells. There are two current competitors for silicon microcells: cadmium telluride and copper indium gallium selenide. It is believed that the efficiency of these materials will eventually surpass silicon. However, cadmium is toxic to humans, and these materials are 20,000 to 300 million times less abundant than silicon is. Emerging competitors could be perovskite, copper zinc tin sulfide, and quantum dots. The use of quantum dots is especially exciting since changing their size allows the ability to tune the band gaps. This has the potential to absorb more wavelengths of light than silicon is capable of, thus further improving cell efficiency. Two of the largest manufacturers of thin film cells are SunGold Solar and Solar Power. Installations of their products are shown on this slide. Current applications include solar farms, motorhomes and boats, calculators, wristwatches, TV controllers, and roofing tiles. My interest in this topic is to determine if this technology can be embedded into cell phone cases to provide slow charging to phones. And of course, my references. Thank you.